All right. Good morning, good afternoon, good evening, or depending on your time and your location. I'm Engineer Moses Onuafe. Today, I want to discuss on the topic earthing and lightning protection. And this topic is going to be split into two different sections. I want viewers to watch out for the aforementioned topic for better understanding. All right. Now, I want you to understand that earthing is a conductive connection between an electrical circuit or equipment in the earth. It provides a low impedance path for leakage current to flow to the earth. And earthing also is known as grounding, is the process of connecting part of an electrical system to the earth conductive surface. This is done to ensure safety, protect equipment, and maintain system integrity. It provides a low resistance for part of a fault current to flow safely into the ground. And there are two ways we do this: the protective earthing and functional earthing. The protective earthing is connection of all current carrying conductor to earth, while functional earthing is when a certain point of an electrical system are earthed to ensure correct operation of equipment. And there is a need for us to understand properly what protective earthing is. So therefore, protecting earthing is the practice of connecting an exposed metallic part of electrical equipment and system to the earth and low resistance conductor. Why do we have to do this? The reason why we need to do this is to protect people from electric shock if insulation fails or live wire comes in contact with the exposed metallic part or a personnel. To ensure a fault current has a safe path to flow to the ground, which will cause the protective device to operate and disconnect the fault circuit. So there is also a reason why we need to do this. Assuming if a fault occurs in an equipment or appliances, the metal becomes live and dangerous. And that is why a protective earthing provides a low resistance path to ground, and it does not normally carry a current. And there is a need for us to also understand the functional earthing. The functional earthing is the earthing that is done not to protect against electrical shock, but to ensure the proper functioning of all electrical equipment so that they can operate optimally well. To maintain this, there is a reason for us to do this. And what is the reason? Is to maintain a correct operation of device or circuit or communication system. Another reason is to provide a reference potential, like maybe a 0 volt for a sensitive equipment. And the second reason is to reduce noise or electromagnetic interference with some equipment, especially communication equipment. And now, let's look at the scenario of a functional earthing. It's a neutral earthing in a power system, the neutral point of a transformer or generator earthed to stabilize the system voltage during normal operation. And this is applicable to electronics equipment, computer, telecommunication system, and audio equipment often function the earthing to avoid noise or the rest. And if you look at the slide, there is a picture of a transformer that the neutral is well earthed to the ground. This is a result of an example of a functional earthing. I want you to understand that there are other types of earthing system. We have types of earthing system, which is TNX. And this TNS is separate the neutral and the earth conductor from source to load. While the TNCS, it combines the neutral and the earth to part of our system. Then the TT, which is the normally another type of earthing system, is the earth connection independent of supply source. Then TNC is a neutral and earth combined throughout the installation. I want us to throw more light on it. On TNCS earthing system, the TNCS system is one of the most common earthing systems used in low voltage electrical installation, especially in a residential area or a commercial area. So this TNC system, the T is the source of connection direct to the earth, while the neutral is installed has a neutral conductor, while the CS combine the separate neutral to combine one conductor, which is PNE, in part of the system separating to the rest. Now, if you look at the drawing, you will see that we have a PN, which is protective, earthing, and neutral. So definitely on this very connection, you have the neutral connected to the earthing system, which is a PEN system. Now, there's a need also know what is another type of the earthing system, which is TNS earthing system. This TNS system is an electrical earthing arrangement where the neutral and the protective earthing PE conductor are separated throughout the entire system from the supply transformer to the end user. Let's say, for instance, for an example, let's look at an urban residential power supply. An urban residential power supply where, let's say, for instance, a housing estate supplied by an underground cable network. The supply company, the company might be any of these DISCO. The supply company provided a 4-core underground cable, which is regarded as armored cable, and separates the earth conductor, which is PE, which is PE connected to the transformer melter sheets or armory. Then each house has its consumer earth terminal connected to this protective earthing, which is known as PE conductor. Why do we have to use this TNS? There is the reason for us to use this TNS, and the reason is that the underground cable armoring or lead sheets or steel wire armor provide a reliable earth path, reducing electrical noise and fault potential. Now, if you look at this system, is also applicable to an industrial area also, but basically a residential and commercial area. Now, another type of this earthing system is TT earthing system. On this TT earthing system, this is a system of earthing arrangement where one point of a power source is directly connected to the earth. The exposed productive part is also connected to the earth electrode. Now, the T in this case means the power is earthed. The second T means that the earth protective earth conductor, which is PE, is connected to expose conductive part to the earth electrode. And in this, ROCD is essential to disconnect leakage current and disconnect supply quickly. Now, if you look at this DMC, let's take for instance, for an example, in the rural area or a rural house or cottage supplied by overhead line in an area where an utility does not provide an earth connection. Just like in our areas now, you see an utility supply without an earth down to the residential. Then let's set this up. To set this up, a supply company give only life and neutral in the residential, and the house install it on earth electrode. The house that is supplied by this utility, which is life and neutral, will now install their own earthing system by using earth electrode. And this earthing electrode will now be terminated to earth rod. If you look at the diagram below, you will see that the utility supply this very particular residential with all connection with live and neutral. And this live and neutral are connected to the distribution board, which is a consumer unit. And for them to have their own earthing system, because there is no earthing system connected to this very particular TT earthing system, they have to use an earth rod to connect to the what? Residential, to every part of all the electronics device at that residential. This is done just to ensure that a protection is paramount on that very particular area. No reliable mentalist return path from the utility or independent local earthing giving a safe flexibility. That is just what we can achieve. And anybody that is using this TT system of earthing should ensure that the input supply to the distribution panel should be provided with what? ROCD, which is residual current device. Now, there is a need for us to also understand that in earthing is very effective, is something that we need to ensure that we do to ensure the safety of our equipment and the reliability of our equipment functionality and the safety of all personnel living on that residential or an industrial area. I want you to share this video and also watch out for the other second section of this topic. Thank you.